Hello, I am Satyabrata. Welcome to my channel. If you want to get new video updates, then please subscribe my channel. So today I am going to explain sp hybridization. To explain the sp hybridization, I have chosen ethine, which is the simplest alkyne, as a template. So to explain the tetravalency of carbon, we have to consider the excited state. So excited state electronic configuration is 2s1, 2px1, 2py1, 2pz1. So the carbons of an alkyne triple bond are sp hybridized. In this hybridization, the carbon 2s orbital is hybridized with any one of the three available p orbitals. Here I have chosen 2s and 2px. So 2s and 2px are hybridized to form two sp hybridized orbital, and the 2py and 2py and 2pz is unhybridized one. They are unhybridized orbital. So as two orbitals are mixed, the result is two hybrid orbitals and two unhybridized 2py and 2pz orbital. Each hybridized orbital has one part that is 50% s character. So sp hybridized orbital has 50% s character and 50% p character. Here actually I have chosen 2s and 2px, so you can choose 2s and 2py or 2pz. Okay, so now we have to see how sp orbitals look like. So as since the 2px orbital is used for hybridization, and because the 2s orbital is spherical in shape, so the sp hybridized orbitals are along x-axis. Okay, so sp hybridized orbitals are along x-axis. So if you choose 2s and 2py, then the sp hybridized orbital will lie along y-axis. Okay, and the unhybridized p orbital, so say this is 2py and this is 2pz. So each orbital contains one electron. Okay, and the this is one sp hybridized orbital, this another sp hybridized orbital, and they are oriented in the maximum angular separation of 180 degree. This angle is 180 degree. Okay, and obviously 2py and 2pz, the angle between 2py and 2pz are 90 degree. Now see this is the three-dimensional view of ethine molecule. Okay, and this ethine molecule is linear in shape. This is carbon, and this two are carbon, and this is hydrogen atom. Now I will show you how hybridized orbital. I will show you the hybridized orbital in ethine molecule. So conceptually, ethine can be formed in the hybrid orbital model by the bonding of two sp hybridized carbon. So this is one sp hybridized orbital, this is another sp hybridized orbital. Okay, and this sp hybridized orbital makes sigma bond with 1s1 of this hydrogen atom, and this is the same. This sp hybridized orbital makes sigma bond with this 1s1 of hydrogen, and here this is sp sigma bond, each contains one This is the paired electron, bonded paired electron. Now I will show you the hybridized, and I will show you the unhybridized p orbital. This is the unhybridized p orbital of this carbon. This is another unhybridized p orbital of another carbon. Now, so let's see, this is py. So here we are seeing that this is py pi bonding, and let's say this is pz, another unhybridized p orbital, that this is pz. This is pz pi bonding. This is one pi bond, this is another pi bond, and the rest remaining all are sigma bond. This is sp 1s1 sp and 1s1 of sigma bond between sp and 1s1. This is sigma bond between sp and 1s1 of hydrogen, and this is sigma bond between sp hybridized orbital. Clear? Now see, this is three-dimensional view of but 1 in 3-ine. Now I will show you hybridized orbital of but 1 in 3-ine. Let's I am taking this view, and here I will show you only the pi bonding, how pi bonding looks like, because if I show you the sp hybridized orbital and sp2 hybridized orbital here, then the image looks very messy. I am drawing the unhybridized py orbital. See, this is unhybridized py orbital. So we'll have py pi bond, and here again we are drawing another py unhybridized orbital. So here again we will have another py pi bond. So this is sp, this carbon is sp2 hybridized. These two carbons are actually sp2 hybridized. Actually when number of pi bond arising from a carbon is 1, so then it is sp2 hybridized. But see, this number of pi bond arising from this carbon are 2, so these two are sp hybridized. Okay, now I have to show you the another pi bond of this carbon. So this is pz orbital, this is another pz orbital. So here we will have pz pi bond. Clear? So actually the image looks very messy, but because here I have drawn the pz pi bond, py pi bond, so that is why this picture looks very messy. So any triple bonded carbon is in sp hybridization, and but there are some exception, because I have told you that number of pi bond arising from a carbon, if it is 2, then also it will be sp hybridized. So sometimes double bond, and the carbon is, this is suppose this is H2C H2C double bond CH2. So the name of this molecule is Allene. So here it is sp2 hybridized, this one is also sp2 hybridized, but try to concentrate on this carbon. Here number of pi bond arising from the center carbon is 2. This is one pi bond, this is another pi bond. So actually it is sp hybridized. Clear? See, this is the three-dimensional view of Allene. The two terminal carbons are sp2 hybridized and the central carbon is sp hybridized, because I have told you that if if number of pi bond arising from a carbon are 2, then that carbon should be sp hybridized. but here the terminal carbon if you see the a terminal carbon, then here the number of pi bond arising from the terminal carbon is 1. So that is why these two carbons, these two terminal carbons are sp2 hybridized. So you will understand better way if I draw the pi bonding of allene molecule. Let's take this view. Okay, actually the two pi bonds, and this pi bond and these pi bonds are actually perpendicular. So if you are if I show you the perpendicular pi bonds, then I need to draw the plane. See, this is one plane, this is one plane, okay, and this is another plane. Okay, now two methylene groups, see these two methylene, this CH2 and this CH2, so these two methylene groups are perpendicular with each other. Okay, this is one, if say this is py, this is py, so here we will have py pi bond, but here we need to draw the pz. So this is pz and this is another pz of sp hybridized carbon. So this is another pi bond. Let's see, these two pi bonds are actually perpendicular with each other, and this is the beauty of allene molecules. All are double bond, but the central carbon atom is sp hybridized. Okay, so thanks for watching my videos. If you like this video, make sure to subscribe for more. Thank you.